Hey everyone, welcome back to our Python tutorial series. In this video, we will dive into error handling in Python, an essential skill to make your code more reliable and user-friendly. By the end of this video, you will learn how to use try, except, finally, and else blocks, handle specific and multiple exceptions, raise custom exceptions, avoid common mistakes when handling errors. Let's get started. Errors are a part of coding. They happen when your code runs into something unexpected. Instead of letting the program crash, Python lets you handle errors gracefully. What are the types of errors we have in Python? First is syntax error, making in the code structure caught by the interpreter. Runtime errors, errors that occur during execution, like dividing by 0. Logical errors, the code runs but gives incorrect results. Error handling helps prevent runtime crashes and improves user experience. So let's start with the basic example using try and except. How we can use the try and except keyword. So we just write try colon and let's say we'll take number input from a user. So and we will cast it into integer. Input enter a number and print that number. Your number is num. And in the except we'll say value error and we'll print invalid input. Please enter a valid number. Let's run the program now. So it is asking for entering a number. So I will enter the number 24 and it prints your number is 24. Let's say some user doesn't enter the number and instead that will enter the character A and it says invalid input, please enter a valid number. So now the user knows he or she has entered the invalid input and they can correct it next time. So the try block contains the code that might raise an error and the except block handles it gracefully. Let's modify this code little bit. We'll take enter a number 1 and we'll take the number another number 2. Enter a number. What we'll do is we'll take one variable result equal to number 1 by number 2. Instead of this we'll print result. We'll change the result is. And in the except we have this value error invalid input, please enter a valid number. So we have the 0 division error and interpreter will automatically detect this, but we need to catch this error. So here we can print the message error division by 0 is not allowed. So here we have 2 except blocks and 1 try block. Let's run the program. So it is asking for number 1 and we'll enter 24. Number 2 we'll enter 8. So the result is 3. 24 divided by 8 is 3. Let's say number 1 is A and it automatically says invalid input. And we'll run the program again and this time we'll give 24 as a number 1 and for number 2 we'll give A. So it says please enter a valid number. We'll run the program again and we'll enter 24 as number 1 and 0 as number 2 and it says error division by 0 is not allowed. So it has reached to the 0 division error. Python checks each except block from top to bottom until it finds a match. We can also catch multiple exceptions in a single block using a tuple. So instead of this multiple except, we can write it in single line using the tuple. So we just write value error, we'll copy this, mention this, and here we'll write as E. E is an exception object. We'll print the error and we can remove this exception. Here I have missed the double quotes. So now we'll run the program. It's asking for enter number 1. We'll mention A. It says invalid literal for integer with base 10 A. So we have not defined the custom error, so it is giving the default value error. Now let's run the program again and we'll give the division by 0, 24 and 0. So it says error division by 0. The else block runs only if no exceptions are raised in the try block. Now in this same example we have this number 1 and this result 10 divided by number 1. So we'll just slightly modify this 10 divided by number 1, and we have print the result. In the except we'll say 0 division error, division by 0 is not allowed. And after this we can mention, else we can say division was successful. We can put this result value here. Just remove that result value. Let's run the program. It's asking for number 1. We'll mention 24. It says division was successful. Then the output is, let's say if we enter the 0, that is 10 divided by 0, it says error, division by 0 is not allowed, and it will go to the 0 division error. We also have the finally block, which always executes no matter what. It's typically used for cleanup tasks. So here I have created one small code using the file operations. So you will see this file open, file.read, file.close in the next video. In this video, to understand, let's say open means opening a file.read means reading that file, and file.close means closing the file. So once we open the file, we need to close that file. So now let's run the program and see what is the output. So it says file not found because the file which is there, example, it's not available in our desktop, but we have the sample file, sample.txt. Finally is crucial when working with resources that needs clean, like files or database connection. After executing, it will close that file, and if there are any database connection, that can also be disconnected. We can also raise our own exception using the raise keyword. Let's see that by example. We have the age and we'll take the input from the user. The age value is less than 0 because age cannot be negative. So here we have to raise value error, mention age cannot be less than 0, else we'll print the age which was entered in our case. Let's run the program. It's asking for age. We'll enter 24. It says your age is 24. Let's run the program again and we'll enter -1. So it says the value error, age cannot be less than 0. So raising exceptions manually is helpful for input validation and enforcing constraints. Let's create a simple calculator that uses error handling to ensure safe input and operations. So here I have created the one function called save calculator, and in the try block I have mentioned number 1, that is float, enter the first number and the second number, and I have also given the operation which can be chosen, and that these 3 are the inputs. Inside this try block we'll write if operation is plus, then we'll add, if it is minus we'll subtract, multiply and division, so on. If the invalid operation is there, then we'll print the invalid. And in the except we can mention the value error, that is we have to input the correct value, that is only the numeric value. If other character or if any other alphabets are given as an input, then we can raise this value error. If the operator is chosen as divided, and if we give number 2 as 0, then we raise this error. And finally the calculation is completed, and this function is called here. So let's run the program. So it's asking for first number, we'll say 21, second number is 32, asking for operation, so we'll mention plus. So the result is 53 and calculation is completed. As you can see, the finally blocks will execute no matter what. Now let's run the program again. We'll mention 21 and second number as 0, and we'll choose division as the operator, and it says error, division by 0 is not allowed. Calculation is completed. Even though the exception is caught, still execute that finally block. This example showcases how to handle input validation and prevent program crashes. Forgetting to close resources like files. Using broad exception handling, exception without specific cases. Ignoring errors silently. Always provide useful feedback. Raising exceptions unnecessarily when simple validation can be used. Great job! You have learned how to handle errors in Python effectively. Proper error handling makes your program robust and user-friendly. If you found this video helpful, give it a thumbs up and subscribe for more Python tutorials. See you in the next video, and happy coding.